Okay, we're looking at a graphing problem. It's a question from exercise 3F, question 2D. And in this question it's asked us to sketch this graph by hand. This is the function that we're sketching. First thing we need to do is basically understand what was the original graph, what did it look like, and then understand what sort of transformations have taken place. The original graph would have been 1 over x squared, which is what we call a truncus graph. Truncus graph because basically it forms a shape like the trunk of a tree. You have to know these graphs. Truncus graph to start with. This graph has undergone some transformations. The -1 or the -1 here has moved the graph down one position. The -1 here has moved the graph to the right one position. The 2 has performed a dilation of factor 2 from the x-axis, moves away from the x-axis. We know the original graph, we know the transformations that have taken place. What we need to do for this particular function is graph the asymptotes. That's our best starting point. The asymptotes have moved to the right one, so x equals 0 becomes x equals 1, and the graph has also moved down one, so the asymptote at y equals 0 becomes y equals -1. In this case we call it fx equals -1. That's our starting point. The form of the graph stays the same, still a truncus. Hasn't undergone any other transformations that's going to change that. The graph's going to go through the x-intercept. At this point, we don't know the value yet, so I'm just going to call it x1. The graph will also, the left-hand side of the graph is also going to go through the x-axis, but I'm not too sure where at the moment. Will it go through the positive values of x or the negative values? I don't know, so before I do anything, I'm going to have to work out the x and y intercepts. Now this is an extremely important concept that you need to make sure you understand. How to find x and y intercepts of any types of graph. X-intercept when y equals 0. So in this case, let's make y, or we call it fx, equal to 0. And we get this equation to solve. One unknown, one equation, we should have no problem solving it. Just by forming transformations. Move 1 to the other side of the graph. And what we can do then, we can multiply both sides by x minus 1 squared. Left-hand side becomes x minus 1 squared equal to 2. We have to undo the square. We'll take the square root of both sides. So the left-hand side becomes x minus 1. The right-hand side becomes square root 2. However, when we do a square root, we can get a plus or minus answer. Plus or minus. We need to add 1 to both sides of the equation. So we get two solutions here. We get the plus square root 2 plus 1, and we get another solution, x equals the negative square root 2 plus 1. This is obviously the right-hand x-intercept, so we're going to call that x1. That goes here. I'm not even going to write it in. I've labelled x1, so that's sufficient for my answer. But I definitely know that that's the positive x-intercept. This is the other side. Is it negative or positive x-intercept? Think about it. Minus square root 2. What is square root 2 approximately? We know square root 1 is 1, we know square root 4 is 2. It's going to be in between 1 and 2. I'm going to say about minus 1.4. Minus 1.4 plus 1 is about minus 0.4. So it definitely goes through the negative side of the x of the x values. My truncus graph is going to do this thing, and I'm going to call that x2. I'm not going to write it in. Sufficient to write x2 here, so I know exactly what the values are. I found my x-intercepts. I need to find my y-intercept. What's my y-intercept? And then I'm done. Y-intercept when x equals 0, because when I'm at the y-axis, x is equal to 0. So I need to evaluate f0. That becomes 2 over 0 minus 1 squared, take away 1. We evaluate that. Minus 1 squared is 1. 2 divided by 1 is 2. 2 minus 1 is 1. So my y-intercept is 1. That's all you need to do. You need to know all your graphs, starting positions. You need to know transformations, and you need to know how to find the x and y intercepts. Extremely important. So good luck with that.